The first unit in Math 110 is visual problem solving. And what I want you to do is sort of pretend that you are in 4th grade or 3rd grade. And how did you initially learn? By using blocks and tiles and all other kinds of manipulatives. So that's what we're going to do for this section. The purpose of this is that my experience in teaching is that most people really are visual learners. And some of you are going to be just amazing at abstract thinking without having to manipulate anything. I have been all my life one of those people that just really needed to see something or to work something out. I'm real tactile, I'm real visual. So what we're going to do in this particular section is we're going to look at some standard word problems, and we're going to create models from those, so that what we can do is we can see how visually making models and connecting to the algebra is going to help us with our algebra down the road. So we're going to be working with, I'll demonstrate with some popsicle sticks and some tile. If you're at home and you don't happen to have those manipulatives at your house, you will use toothpicks and wheat thins, or something like toothpicks and pretzels. You could do pretzels and M&Ms, whatever you have to manipulate around. That's what I'm going to have you do. And what we're going to do is we're going to take those word problems and we're going to actually create models that will help us ultimately to understand how that connects with the algebra. So in this first section, we're actually not using any algebra. I don't want to see x's, I don't want to see y's, I don't want to see anything but a visual model to help really translate from that word problem to something that we ultimately can solve. And then I promise I'll help you make that bridge to algebra. But I want you to see that X isn't just this abstract thing. It's something that's very concrete that you can see and you can manipulate. So I hope you have fun with this. Just kind of put yourself back into the mind of an elementary student and think about creating pictures and playing with blocks, and just enjoy this piece. We're going to look at example 1 on the back of the problem solving using diagrams and sketches. And we're going to look at the first example here. The first example says, each morning a math teacher runs a total distance of 42 city blocks and always chooses a rectangular running path. This morning her rectangular path was twice as long as it was wide. How many blocks long and how many wide was her path? So using a visual approach, we're gonna use, I've got some popsicle sticks. It took me a long time to eat all these popsicles, but you could use toothpicks, whatever you want. So what we know about a rectangular path is that it was twice as long as it was wide. So if this is her width, then I would need 2 popsicle sticks for her length. So again, a width and then length. So what we've done is we've created a model of her path. 1 block wide, 2 blocks long. Now what we also know about this is that it said she ran 42 blocks total. And when I look at this model, I can see that I have 1, 2, 3, 4, 5, 6 popsicle sticks. The popsicle sticks represent my unknown. I don't know how far each of those popsicle sticks represent. I just don't know that yet. But I do know that there's 6 total of them. So if I have 6 total and I know that she went 42 blocks, what I can do is I can divide 42 by these 6 unknown blocks, these 6 unknown pieces. If I divide 42 by 6, I get 7. So what I know for sure is that each of these popsicle sticks represents 7. So her path was 7 blocks wide and 7 plus 7, or 14, blocks long. Now notice I didn't do any algebra to determine that. We just created a visual model, and from the information we had, we were able to then determine the width and the length of that rectangular block. So right now what we're doing is we're thinking of our popsicle sticks really just of some unknown quantity and going from there. So that's our example of the rectangular running path. There's another example here. If we look at example 2, it says the average of 4 numbers is 7. The second number is twice the first. The third number is 6 more than the second. The fourth number is 2. What is the value of each number? Now, I don't know about you, but these were always the problems that gave me stress. So what we want to do is we again want to use our manipulatives to look at how we could create a visual model. We know something about averaging. If I know that the average of 4 numbers is 7, I can imagine here that I have 4 piles of 7, or I have 28 total. So we know something about average, and that's going to help us out a little bit. Let's go back to the problem and read this. And it says, the second number is twice the first. So I don't know anything specific about that second number or the first. But I do know if I say that my first number is 1 popsicle stick, I have to say that my second number is 2 popsicle sticks. My second number is twice the first. And then we go on, it says the third number is 6 more than the second. This is my second one, so I'm going to put my unknowns. There's exactly the same as the second, but what I know is this one is 6 more. I'm going to introduce another manipulative. I'm just using tile, but if you're at home, you can use your Wheat Thins or your Skittles or your M&Ms. So now what I'm looking at, if I go back, it said my second number was twice the first. My third number was 6 more than the second. So far, I'm good here. It then says that my fourth one is 2. So when I come here, I have no unknown with the fourth one. They're just telling me it's 2. So what I've done in this example is I continue to use my popsicle stick as my unknown. I don't know what it represents. I've introduced the tile to represent a given quantity. In this case, I'm saying each of my tile has a value of 1. So here's my model. My second is twice the first, my third is 6 more than my second one, and my fourth one is 2. So how do I use this information? What I know is that the total quantity represented here is 28. So of that 28, this is what I know. I know I have 1, 2, 3, 4, 5, 6, 7, 8. I have 8 that I know. If I take the 20 and I subtract off the 8, I know that what is represented by these popsicle sticks is 20. So what I need to determine is if this total is 20 and I have 5 popsicle sticks, how much is each of my popsicle sticks? So if I take 20 and I divide it by 5, I would get 4. So my first number, which was 1 popsicle stick, is going to be 4. My second number was 2 popsicle sticks. That's going to be 8. My third popsicle stick, my third number was 6 more than twice that, or 6 more than the second one. So now I have 8 plus 1, 2, 3, 4, 5, 6, or I have 14, and my last one is 2. We can go back and check. So we have 4 plus 8 is 12, plus another 8 is 20, plus 6 is 26, plus 2 is 28. So with this visual model, we can determine what each of the values are.